Then it will ask you what are the conditions. Look at the point, where is the point of projection? The point of projection is not on the inclined plane, no, somewhere. Can we work out as it is? So what we should know, where it will strike the inclined plane. So this you call x1, this will be y, and this will be x, no? At t equals 0, you are projected. After some time, it will go and strike here. So what is a x is equal to u cos theta into t, y equal to u sin theta t minus gt square. He's telling himself it will strike normally. Since we know this angle, we know this angle, so we can bring that particular condition. It strikes normally, so you resolve velocity here. So here the two velocities will be there. This will be vx, this will be vy. If this is alpha, 90 minus alpha, this should be alpha, no? So here what is tan alpha? You can write it. Tan alpha as vx by vy. From tan alpha, what happened? I'll get expression for vx and vy. What is vx? Vx, we know u cos theta. See, I'm telling this one. So don't expect that inclined projectile problem will be like this. The point of projection can be somewhere on the ground also. If it strikes normally, if I put a condition, stone strikes normally at point P on an incline. This is a condition. So once it strikes normally means I get relation between Vx and Vy, and we know horizontal component of velocity should be constant. Is that okay? So I know Vx, I know alpha. Can I get Vy? Yes, I'll get Vy. So Vy equal to Vx by tan alpha or u cos theta by tan. U theta and alpha, you know, you'll get Vy. If you know Vy, you can calculate time. U sin theta minus gt. So you'll get the time. Once you know time, then you can get the value of x. Once you know x, then you can get the value of y. Once you know time, I think you can get the value of y. From y, you can get the x1. From x1, all other things. See, these are some best numericals that are available. So the point of projection need not be always on inclined plane. It can be somewhere. We discussed earlier, some it was at some, it will strike normally. I can project from the ground. So even if I give that, it will not strike normally, some angle also you can manage. Please do work out some numericals of these kind. So for exam, definitely the teacher who is going to set paper, no, you will try to see how student can analyze in different ways. I can also do like this. So just go for generalized thinking. What I suggest students is like rather than confining to some 10 or 15 problems, no. So instead of that, somebody mute it, mute it, please, mute it. Please mute it. Okay, now you see that one. The same problem can be asked in for even several ways. No, I'll project here horizontally. Let this be alpha, this beta, so that it will strike the other inclined plane, making some angle. Called theta, where theta is definitely it should be greater than 90. Let's take something. I can do like this. No, earlier we did projected vertically. Let it be projected horizontally, or say like a alpha it is. Then he'll ask you all the conditions. So how much of distance it will move? I'll give this distance as a. To strike this, it will move a distance a, no? No, resolve the velocities. So one perpendicular. able to manage. So you do one thing, rather than searching for questions, no, you take one inclined plane, ground, two inclined planes, inclined plane and ground. Analyze all the possible cases. If it moves like this, how, if I project like this, how do it move? If I project like this, how do it move? This is what needed for student. Not like, don't go for searching questions. Already around 15 questions I discussed. Almost the major concepts I covered it. The remaining thing, what happen, you analyze on your own. How do it will move? Fine, all of you. Hmm? So this is about the inclined projectile, almost like a 3 classes I confined for this. Tomorrow we'll start the relative motion, relative, accelerated,